In this video, we're going to be showing you how we added air conditioning for the very first time to this house that in its 35 years of existence has never had it. Not only that, but we saved the homeowner about $8,000 in the process, and we did it all today. I'm here with my buddy Dave from DIY HVAC Guy. You've probably seen this channel before. Thanks for joining us, Dave.
Absolutely.
He's our guide walking us through this entire process. We're going to show you every step of the way in case this is something you're interested in doing. It's actually easier than you might think and will save you so much money. And the best part is we're doing this at a customer's house where we're going to actually surprise her at the end with the fact that we're doing all of this absolutely free. Why don't you tell her the price?
The price is...
It's what?
All right, so here's what we got down at the basement. So we have our existing furnace. This and the coil was replaced in, I think, 2019. And so the coil is already set up. We don't have to do any duct work, but I do have other videos that show how to build this transition. Now, part of the challenge is finding what the best route to run the refrigerant lines out to the condenser, where to put the condenser. So we're gonna go outside and show you what the ideal location is. Something else you wanna factor in is this is our utility room. And you notice all of the floor joists are going this way. So initially, we were wanting to put the unit here because it's closer physically, but the location out here is not ideal. It's gonna be a real challenge because the floor joists are going this way. So we're gonna patch this, and we've come up with another solution that is way better. So since the floor joists are going this way, if you look right here, you can see outside, and we'll show you where this goes outside. This is just using this as a fresh air supply to get supply air into this utility room. So we can now run our line set straight through this floor joist in this cavity, and it's gonna be way, way easier than trying to run it, through here and fishing it through there. That was just gonna be a nightmare. Not to mention, we would have to run a new breaker and run electrical out there with a disconnect, but we'll show you out here how it works with where we're gonna put it now. So originally we were gonna put the condenser here, but as you can see, this is a covered space, not to mention they wanna use this space, in the summer months and the spring and fall to entertain. So this is where we're actually going to be putting it. It's in this area that nothing is going on. The noise doesn't matter. And as you can see, that's that fresh air that we saw light through from that same cavity. So we're just gonna cut a hole about 2 or 3 inches here, run it out, do a 90 with our refrigerant lines. We're gonna set a pad here and put our new condenser right here. By the way, this is the new condenser. It's an ACIQ 3-ton condenser. Part of this home is in the basement, so normally we would have sized this a little bit bigger, but because it's a basement, 3-ton is gonna be perfect size for this. And then, being as the panel is right here, we have additional slots right there. So we're gonna put a 30-amp breaker on those slots, label it AC, and as long as it's within 6 feet of this breaker, we don't have to have a disconnect here, which is an added bonus. So this is our line set. This is 7/8 and 3/4. And what we're gonna do here is we're simply going to orient this to where we can hold this one end with our foot, and we're just gonna roll it out, and that ensures that this comes out as one long straight piece. And then what we're actually gonna do is we're gonna tape the 3/8 line, the thermostat line as well, all together, and then we're gonna feed it through that chase, and it's gonna be super easy. Something else to note is we're gonna give ourselves about an extra 5 feet or so. So we're just gonna tape it like this. That way we have some extra to make our attachments.
So Dave is bundling this 18.5 communication wire with the line set with electrical tape every couple of feet. And while watching this back, I discovered this little gem that I didn't know about at the time.
Stepped in a pile of crap and it stinks. I didn't even know they have a dog.
Sorry about that, Dave. They actually don't have a dog, so I guess we'll blame the neighbors.
So we're just feeding this through. So now what we're gonna do is do a gradual bend right here, and then we should be pretty close. We might need to feed in a little bit more, but we should be super close here. Now, something else that's very important is we want to ream this out with a special reaming tool. You can get this on Amazon. And basically, as you can see, we're just removing and kind of expanding the inside of this, because when you run your tubing cutter, it actually shrinks this down and kind of restricts the refrigerant that will flow through that. So we want to open all of our lines, the larger line as well as the smaller line. And you always want to make sure that this is tilted down so that none of this is actually getting in your pipe. So this one's going to go right here. Let's go ahead and throw our filter dryer in. And we're just doing a dry fit here to make sure that everything looks good. Perfect. Okay, so now that we have everything dry fitted, let's remove our liquid line, and we're going to show you how to prep these lines for our Stay Bright 8. So the first thing we need to do is just clean it up with some Scotch Brite or some emery cloth on the ends. And then once all of our joints have been cleaned up, just like that, we're going to apply our flux. So this is what we're going to be using today. This is called Stay Bright 8, and this is a specialty soft solder that's specifically designed for HVAC applications. Now, there's several advantages to Stay Bright 8, and the first of which is you don't have to flow nitrogen through these lines. This does not get nearly as hot as brazing, which is typically about 1200 degrees, so you don't have to worry about soot getting built up in these lines. And the other advantage is you can use a simple MAP or propane torch and use this. You don't have to use the yellow tank. You can use the blue propane torch with a simple torch head like this. This only gets to about 400 degrees, so it's very quick and very easy and DIY friendly. So now that all of our fittings have been sanded and cleaned up real nice, we're just going to go back through with our Stay Clean. This is our flux, and we're just going to use a little amount of this. You don't have to use a ton, and I only install this on the male end. So for this one, we're just going to go not quite to the edge there, just almost to it, all the way around. And then when you feed this in, it will push that flux towards the outside, so a minimal amount will get into the lines. So we're just going to go through and put this on all of the male ends. And we'll go ahead and put our filter dryer in, again with the arrow pointing towards the furnace or towards the coil. All right, let's do the same thing on our suction line, and then we'll be ready to solder. Now, something else to note is that this unit came with these rubber boots. So you'll notice we slid them up so they're away from the heat. And then once everything is cooled, we'll slide that back in to seal this from air coming out. Now you'll notice when I start soldering that we're going to start on the opposite side, heating it up, and we're going to feed the solder in through the other side, making sure that the solder gets pulled where that heat is going. And then we'll also move the heat source to the other side, feed in a little bit more to make sure that we have a good seal all the way around.
So as you're watching this, you'll notice that he's practicing exactly what he told you there. He's applying the solder to the opposite side that he's heating, and he just uses this little swiping motion. Does that a few times until he notices that the solder melts appropriately. Then he removes the heat and then continues applying that, and he'll kind of work his way around the pipe until he gets a great seal. He's also getting a good buildup on there, so the solder actually kind of gets sucked into the joint, but he's making sure not only does it get in the joint, but it builds up around the joint too. And then later on we'll see that he's going to sand it all back down, apply a little bit more flux, and then move on to the other joints. I think a lot of people are often intimidated by sweating pipes, but it's actually just about as easy as it looks. And this is something that you have some forgiveness with. I've sweated pipes in the past and was a little intimidated myself, but it goes pretty smoothly. And keep in mind that you will use more solder for a larger diameter pipe than you will for a smaller pipe. So you'll notice when he moves to the 3/8 inch pipe, there's very little solder that's actually being used.
right, that is it. All right, so we just wiped all of our joints down and everything looks really good. We're just gonna go back through with a mirror and make sure that we have really good coverage all the way around. Looks good. Now this is just a 3/4 threaded fitting, and it goes to a female. So we'll put our male 3/4 PVC in here, and then just 90 over and 90 down.
So what Dave's building here is called a condensate pipe. This makes sure that any water that accumulates via condensation inside the unit doesn't get stuck in the wrong place, and it's got a nice path to flow to. There is a drain in the floor in this utility closet, and this one was a little bit different than what I've experienced in the past. It's actually sitting underneath the water heater. So he's building a nice PVC pipe that goes out the exit around that main vent that you see in the middle of the screen here, down and into the floor where there's that drain pipe that it can all drain into.
All right, so there's the finished drain. Just come down and go into the drain that's under this water heater. So that part is finished. Our line set is also finished up. We're just gonna do our soldering outside and then do our pressure test, and we'll go from there.
At this point, you might be wondering if I was actually helping at all, and I promise I was trying. While he was doing a lot of this stuff in the basement, I was out picking up the different supplies that we needed, many of which you'll see later on in the video, including this 3 by 3 foot condenser unit pad. I didn't know this was an option. It's really pretty handy, so instead of pouring a concrete pad and waiting for it to set, all we had to do was go buy this thing, and then I used a flat end shovel to mark a template around it and then dig out what is essentially sod so that I could have a nice spot to set that into the grass. And then I was able to level it just using a small level and then make sure everything sat totally flat. And once that was done, I could put the condenser unit itself onto it and push it down, and everything was good to go. This was actually a super easy way to get a nice solid base for our condenser unit. From this point forward, I was able to focus on the electrical side of things, and we totally lucked out because there was a 20 amp single pole circuit breaker in place there that wasn't actually in use. So I was able to switch it out with this 2-pole 30 amp breaker, which is what we use to power the unit. From there, I knocked out one of the little knockouts at the bottom and then used this 6-foot 1/2 inch ultra whip. At least that's what some people call it. Basically, it's an outdoor rated whip, and it's also got all of the wiring inside of it, which makes this really convenient and easy. These cost about 17 bucks, and if you can see past my bony elbow there, you'll see that I took the locking nut off, fed the wires up, put the locking nut back on in place, and I have this handy little set of Klein nut adjusters. Maybe that's not the technical term, but little tools that actually use the teeth on the locking nut to pull the rings around and tighten them up. They work really well. These are definitely optional. You can use just a regular pair of pliers to do this too. You'll notice a lot of times in this video I'm using my Kinepex universal wire strippers here. They can take really any gauge wire, stranded or solid, and strip them really quickly and easily. And then once I was done with that, I used my lineman's pliers to twist the stranded wires together to try to make them more like one solid wire. From there, I hooked the red and the black up to the 2 poles of the circuit breaker, and it doesn't matter which order, they're both pumping out 120 volts, so that's fine. And then I put my green ground into the ground bus bar. Next up, I was able to feed the other end into the unit itself, and essentially we're doing the same thing over here. We put that locking nut over the top, and then we tighten that thing into place. I'm going to cut the wires to length, both the ground and then the hot lines, and then once they're in place, I'm going to twist them together and connect them to their terminals. Just like before, it doesn't matter if you put the red on the left or the right, or the black on the left or the right, it's all the same. They all get their 120 volts per leg. As is the case with a lot of the tools you'll see us using here, you don't have to have specialty tools like my universal wire strippers, but this is how your product should end up looking at the end, with the 2 legs and the ground. Now from here, I used my multimeter just to make sure that we had good power coming in at the source as well as at the unit, and it's hard to see, but there was 232 volts coming into each. With our power situation all squared away, it was time to focus on those communication wires that we put in before. This is the 18.5 cable, and I'm just connecting the red wire to the brown and then the white wire to the blue, and that provides the signal to tell the unit to turn on. You can of course use wire nuts with this, but I chose to use some 2-port WAGO connectors to make this fast and simple.
So as you can see, this furnace is only set up with 2 wires, one for 24-volt supply and one for the call for heating, because this was a furnace only setup. So what we're going to be adding is called a FastStat 5000, and it has a unit that'll go right here, and it will extend via Bluetooth. It will send a communication for the Y terminal to call for cooling, and the C terminal, which we'll need for certain thermostats, and it'll send a signal via Bluetooth to the thermostat, and it communicates really nicely with the system. That way you don't have to pull a new wire and go through all that mess. So we'll show you how to do that now.
So the FastStat 5000 actually comes with a pretty thorough manual, and it's got some great diagrams showing how to connect a 2-wire setup as well as a 3-wire setup. And I realized it probably didn't make a lot of sense for me to show the specifics of how ours is set up, because everyone might be a little bit different depending on your board. So first we're going to start with the board down here at the furnace and make sure everything is connected as explained in the diagram. Close everything up and make sure we're good to go. Then we can move up here to the thermostat and just make sure to remove that carefully, and then we want to expose all of the wires. Remove each of the wires there and then pull off your mounting plate. And once the mounting plate's off, the challenge we have now is to be able to figure out how to put the little transmitter into the wall, this guy. So this thing actually needs to go behind the drywall, but of course this couldn't go simple because really everything else in this project did go pretty simple, so I had to have some challenges, right? So I actually ended up having to find out how to put this into the wall, because those 2 wires were coming out of the middle of 2 2x4s. So I had to drill out the space that was just a little bit bigger than the transmitter, being super careful not to actually connect with those wires, because that would ruin the whole thing. So you can see right at the end, I think I barely just pushed on those, but everything was still intact and in good shape. So then I shoved that little transmitter into there, got all my wires poking out, and then mounted them through the mounting plate afterward. Once I had the mounting plate put on again, I was able to snip the wires to a reasonable length because there just wasn't enough room for all of them, and then strip the ends of each one, again using my handy dandy Knipex universal wire strippers, and then got everything wired up. And of course, I actually didn't do it quite right, so I had to have Dave come and help me because he's done this many times and I wasn't putting the common wire in the right place. But once we did get it in the right place, we mounted the wire again, and as you can see, it was 85 degrees inside the house.
Alright, so here's where we're at out here. Nils has been working on the outside stuff, so we have our whip connected, which will fasten and make look nice. We have our pad. We dug out a square of the grass and leveled this out, placed our pad and our unit on top. And now we're going to focus on getting our refrigerant lines connected. So what we'll do is cut the insulation about here. We'll use our bender tool to get it right where we want it. And then afterwards we can come back and put our insulation back on. I'll bend this 45 a little bit more. It should be right on.
I have experience using pipe benders for metal conduit, but this was my first time seeing someone do this for HVAC lines, and Dave's a pro at this, made it look pretty easy. He has this set that he's using that's a little more expensive, but I'm putting links in the description to some less expensive sets, especially if you're just going to do this once.
Okay, so we've made our bends here. We're going to go ahead and prep our fittings and our pipes here so that we can Stay Bright 8 this in. And the first thing we're going to do is use our Stay Clean flux, and again, we're not going to use a ton of this. Now, something to keep in mind is you can find these ACR fittings on supplyhouse.com, but don't mistake these fittings for plumbing fittings because they're not the same. The ACR fittings are a little bit thicker than regular plumbing fittings, and they're rated for a lot more pressure. Okay, so that's fluxed. We're going to actually move this unit in. There we go. So we're fully seated there. Both of these lines are ready to go. What we're going to do is use a wet rag to kind of prevent this heat from messing with our valve. You'll note typically I don't do this. I don't really think it's super necessary, but I'm just going to use an extra layer of caution here. We're in and out so fast that it doesn't really have time to soak in and mess up the valve, and I have yet to mess up one of these king valve seals. Another rule of thumb, they say if you take and bend this around the pipe like so, you could actually mark this right here and know that this is about how much Stay Bright 8 you should use. But I usually just do this by feel, and it's never let me down. We'll inspect this with our mirror, and then we'll get some nitrogen on it to do our pressure test. Okay, so what we're gonna do now is take out our valve core, and this is gonna allow us to get the most nitrogen in the system, and this is also going to allow us to pull a really good vacuum instead of trying to pull a vacuum through a tiny little opening like this one. All of your vacuum would be pulled through these tiny little holes here otherwise. So we're going to remove this and hook our valve core tool up, and then when we're done we can simply put the core back in with this tool. So we'll simply thread this on, and then we'll hook our nitrogen up right to this port here. And then we'll hook our nitrogen up there. All right, so we have our nitrogen here. We're simply going to connect our yellow hose right up to our nitrogen, and we're gonna try and put about 300 PSI in this system. We're slowly going to throttle this in. I usually stop around 50 PSI and make sure that we're not dropping like significantly. Okay, so we're at 51.4. We'll give this about 5 minutes and just make sure that it doesn't drop significantly. That way we're not going to throw 300 PSI in it and then find out that we have a leak and then waste all of that nitrogen. Okay, so it's been a few minutes. We're still at 51.4. Let's go ahead and throttle in about 350 PSI, and we'll just make sure that everything holds. So we'll give this a few minutes to stabilize. You'll notice the pressure dropping a little bit after you initially send it in, but after about 5 minutes, this will settle and stay at a certain point. And if it doesn't continue to drop, then we know that we have passed our pressure test. So we settled at about 370 several minutes ago, and it's been holding for probably the past 20 minutes. So we're golden on our pressure test. So what we'll do now is we're gonna close this, take our hose off, and then we're gonna let this all out at once, and it's gonna do kind of like a nitrogen purge and get out any contaminants in the lines. I'm gonna blast all of this air out. So next what we're going to do is pull our vacuum. We're just going to be using this Navac battery powered pump with a Milwaukee converter, but you can do this with a cheaper $100 pump that you can find on Amazon, and this just kind of expedites this process. But we're going to be using the True Blue hose. It's a large diameter hose, and it really helps to pull the vacuum very quickly. So we'll just connect one end here on our core removal tool, and then we'll connect the other end here to our pump. And lastly, what we're going to do is put our micron gauge on the high side, and what this is going to do is tell us exactly how much moisture we've pulled, and we're after 500 microns or less. And again, you can find all of these products on our Amazon store. So we'll simply turn this on and our pump. And once we have the vacuum pulled out of this hose, we'll open this valve and start pulling down these lines. Now, a common misconception that a lot of people have is they think that they have to add the refrigerant, but in reality, all of these units, when you get them, they come pre-charged with enough refrigerant for about 15 feet. And so what we're doing is pulling the all of the moisture and contaminants out of these lines. And then once we're done, we're gonna open these valves, and that's gonna let the pre-charged refrigerant into the rest of the system, and then it'll be ready to go. So we'll open this valve, and you'll notice this pitch change. That means that it's now pulling the vacuum on these lines. And we'll watch this meter, and as soon as we get down to 500 microns, we'll do a decay test. And basically what that is we're making sure that it's staying at a certain level of removing that moisture. If it slowly raises up, we have to pump it down a little bit more, but our target is to be below 500 microns and for it to stay there for at least 5 minutes, and then we're good to go. So you'll notice we're already at 20,000 microns and dropping pretty rapidly. Now, while we're waiting for our system to pump down, I want to mention something about the nitrogen and all of these tools. A lot of people leave me comments saying you have to buy thousands of dollars worth of tools and it negates, any savings. But the reality is these tools, you don't have to get this super expensive setup. I did this for a living, so I have really nice tools. You don't have to get super nice stuff and you can still achieve the same thing. So for all of these tools, you can expect to pay between $1,000 and $1,500, which is really a small number when you compare it to the $7,000 or $8,000 that you could be saving. Now, specifically talking about nitrogen, I went to Air Gas Supply the other day and just asked them how much would it be if I just picked up a tank of nitrogen, and it's basically $10 per day. So it's really cheap to rent nitrogen, and it costs about $30 to refill this tank. So definitely DIY friendly. Just look for a local Air Gas and you can get nitrogen there. All right, guys, as you can see, we're at 300 microns. So we'll go ahead and do our decay test. And all that is we're gonna isolate everything. We're gonna isolate the vacuum pump, and all of this will be under the same reading, basically. So we're holding at 290. Go ahead and turn off our pump. And as long as we hold and we don't rise above 500 within 5 minutes, we're golden. And the last step is to remove these little caps, and we'll unthread the Allen head valves in here, and then we'll be ready to go. As you can hear, the contactor is pulled in, meaning that the fast stat and the thermostat are calling for cooling. So all we have to do is let the refrigerant in, turn our breaker on, and we're good to go. Just so you can see what we did here, so our breaker panel actually had some open slots here. So we're going to just bust these out, and now we have a 30 amp breaker right there, and it's within 6 feet. So we don't have to have a disconnect. As long as we can turn that breaker off and service this unit, we are golden. So it's been over 5 minutes. We're still at 240 microns. So we're golden to open up these valves. Now, some people say to open, and also we want to isolate this first just so refrigerant doesn't go into here. Some people say to open the suction line first, others say to open the liquid. I don't feel like it matters either way. As long as you let it set for 10 minutes or so, let the refrigerant stabilize, you should be good to start it up. And then there's a stopper here. Don't go too hard, just as soon as it stops, you're good. I've heard horror stories of people stripping these out, but it hasn't happened to me yet. You have to really be like doing it knowing that it's not the right size to strip it. Okay, so we'll just snug these up, and then we'll hook our gauges up just to check the pressures. We might have to add a little bit of refrigerant to this system, but we're probably 5 feet more than 15 or maybe 10 feet, so it should be pretty minimal. So we can disconnect our vacuum pump, and then we're gonna put our Schrader core back in. I'll show you how easy that is. So we simply feed it in, and then we slide this middle piece until it locks in. open it up, and then we thread the core back in. And once you feel a little bit of resistance, you know that it's fully seated, and that's it. So we'll take this one off first, and then we'll slowly open this just to make sure that's working like it should. And that's it. Okay, so we're just gonna hook up our gauges and make sure that the pressures look good once we turn this on for the first time. And that's the beauty of these low loss fittings, is you don't have that spurt of refrigerant. It makes it connecting and disconnecting really easy. So if you'll notice right here, we have about 230, 260 give or take. And once we start the system up, we're looking for about 130 and maybe 350 on the high side. So we're pretty much ready to start it up. I'm also going to throw these on so we can check our subcooling and superheat, and we'll show you that as well. All right. Moment of truth. Ready?
Yeah.
That's what we like to hear. So we'll give this a minute to find its pressure, and typically you want to give it about 10-15 minutes to check the subcooling and superheat, and that way you give it enough time to for the TXV to adjust and get a consistent reading.
Now for the exciting part, we turn the cool on, we set it down to 70 degrees, and then you kind of sit back and watch the house cool down and monitor the temperature coming out of the vents.
All right, so as you can see, it's 85 degrees inside, and let's show you what we're blowing out of the vents here. As you can see, we're currently blowing 56 degrees. Typically, we want to have a 20-degree difference. So if we start with 85, 75, 65, we're blowing closer to 30 degrees. So we're getting a lot of cooling, and we'll be able to dial this even further in with our refrigerant charge. But so far it's cooling perfectly. We've got nice cool air coming out of the vents. Pressures are looking really good, but as you can see, our subcooling is low. We want this to be about 8 degrees. And so if you look on the front panel or the electrical panel here, you'll see that our target subcooling is 8 degrees. So that's the number we're after. But because there's such a large heat load, as you saw, it's 85 degrees in the house, we can't really dial it in with the subcooling. So what we're actually gonna do is we're gonna weigh in the refrigerant with a scale. So these units all come pre-charged with 15 feet of line set. And so we installed a 30-foot line set, and we had about 5 feet additional. So we have 25 total feet. That means we need to add charge for 10 additional feet. Now we're gonna add 0.6 ounces per foot, and that's gonna add up to 6 ounces that we're gonna add. So to start with, we're just gonna hook up our middle hose here, the yellow one, to our tank. Now that that's tight, we'll open it up, and we're gonna bleed all of the air out of these lines. So when we hooked up these hoses, a little bit of air got trapped right here. So we're just gonna bleed it out. Just gonna let a little spurt out. This one has a little bit of liquid in it, and that's it. So all the air is out now. Now what we're gonna do is flip this upside down on our scale. And over here on this screen, we're gonna turn it on and we're gonna zero it out. So right now this weighs about 11 pounds. We're gonna zero this out, and we're gonna slowly start adding refrigerant through the low side. And we'll notice this number going up. We're gonna go in slowly until we get to 6 ounces. All right, guys, so here's the finished product. fan is running, our condenser is on outside. This line is nice and cold. Everything is insulated all the way up. Got our filter dryer there. And this is our finished condensate drain going down under the water heater there. And that's pretty much it for the inside. We got nice airflow. We made sure that the filter was brand new, it was just replaced. So we got plenty of airflow coming out of the vents. This system is ready to go. So we just got done weighing in 6 ounces. I apologize, my camera went dead. As you can see, we're still not at the target subcooling, but that's okay. Once the temperature in the home gets down to closer to what it's set for, our subcooling should be closer to that 8 degrees. As you can see, it does fluctuate when the TXV opens and closes, so we're actually pretty close. So everything is golden. We've got super warm air coming out here, cold air coming out of the vents, and we're good to disconnect our gauges, and this system will be completely done. Well guys, this is the finished product, running beautifully, pulling tons and tons of heat. Icicles are coming out of the vents. Everything about this job turned out really easy. Our line here is beer can cold. Everything turned out really nicely here. We have a few items that Nils is gonna wrap up for us. We're gonna seal that off there to make sure no critters get in. But other than that, everything is ready to go.
Okay, and with that, it is now time for the big reveal. Time to sit down with my mother-in-law and explain exactly what we did and how much it's gonna cost her. This is Kathy, my mother-in-law. How long have you lived in this house?
37 years.
37 years.
I didn't think it was that long, but 37 years.
Wow. How have you stayed cool?
So a lot of my neighbors have gotten air conditioning.
And you've been talking about it for several years and been saving your pennies, right? And then you had a setback recently, right? With an unexpected expense?
Yeah, my sprinkler system has caused a lot of problems.
Yeah.
But it's 37 years old.
It's been around the block, hasn't it?
I know.
So how much did that cost you?
This year is cost about $3,000. Last summer it was about 35.
Holy moly.
Yeah.
Okay.
The guy that worked on it this summer claims it wasn't done right, so I'm not sure who to trust.
All right, so now we have the fun part. We get to talk to you about how much you owe us.
Yes.
And that feels weird saying it that way, but what the bill is.
Yeah, it took a little bit longer, so
yeah,
we might have to charge a little bit extra for that.
Yeah, it did take a little longer. We had to get some extra parts. We had to do the pad underneath the air conditioner condenser unit. Any guesses at what the price is going to be?
Well, I told you what I had, so I'm just planning on about $7,000.
About $7,000, okay.
Because my friend who lives in the condos had to replace her furnace and air conditioning. She told me the other day it cost $13,000.
Oh my goodness.
Wow.
Okay, very expensive.
To have that done.
Yeah.
So.
Well, Dave, why don't you tell her the price?
The price is $0.
It's what?
$0.
No. No,
Yep.
you guys.
Totally free, our gift to you.
No, I can't do that.
You can.
No. That thing out there costs money.
Yeah, it's our gift.
You can buy whatever you want for $7,000.
You got $7,000 that you were planning on spending. Plan that or spend that on something fun or something else. I don't know.
Please,
No,
please, let me pay
Just
you.
enjoy your AC and...
That's really, really hard. Because I want to do my part too.
You've been doing your part all your life.
No, but I don't expect something for nothing.
We know. That's what makes this enjoyable for us, is you don't expect it.
That's why it's taken us this long to tell you that it's free.
Oh, you guys. Oh, I'm really having a hard time with this. I really wish you'd let me pay you.
We'll let you buy us lunch next time.
Yeah, we'll come back for lunch next time.
Oh my goodness. I cannot believe this. I absolutely cannot believe it. I just cannot believe that you're doing this. I am just in total shock. Oh my goodness.
Well, this makes us really happy. So you've provided joy for us. So
Well, thank you so much.
of course.
You're very welcome. We had a great time doing this project. It was awesome to do something good for someone who deserves it, and a huge thank you to Dave for making this all possible with his expertise. If you want to check out his channel and send him some love, you can click on his channel here. And if you want to learn how to install a mini split where you don't have connections for an air conditioner unit, you can check that out there. I'm Nils with Learn to DIY. Thanks for watching.